This is the third video for chapter 6, which is on reciprocal trig. So in this video, I'm going to look at finding exact values and solving trig equations. So when we talk about finding exact values, really we need to avoid using our calculator because the calculator can lead us astray a little bit. So we'll look at these, and again we're going to use some of the knowledge that we've already come across. So it says, given that sine A is 5/13, so this trig ratio is 5/13, and the A is obtuse, so that's quite important, we know that A is obtuse. Then the exact value of cosec A, cos A, and cot A. Right, so the first thing we've got to look at, of course, is cosec A is 1 over sine of A. So it's the reciprocal sine A, so that's 1 over 5/13, which is 13/5. Now we've just got to, so that's just a basic reciprocal, 5/13. So we get 13/5. Now we've got to be a little bit careful. Right, so I want cos of A. So the first thing I'm going to do is I'm going to use the given bit of information, this bit of information, that sine A is 5/13. Just move that so you can see it. In fact, I'm going to rub it out because I've obliterated it. Okay, but we know that A is obtuse. Now to get cos A, what we do is we just first of all pretend that A isn't obtuse, that it's actually acute, and we draw a little right angle triangle, and here it is. Okay, so here's A, and we're going to pretend that A is acute to start with, just to find the ratio. Okay, so you know that sine is opposite over hypotenuse. So we're just using basic trigonometry, remember. So opposite hypotenuse, the opposite will be 5, the hypotenuse will be 13. And from Pythagoras, we can work out the adjacent will be 12. Okay, so therefore cos of A will equal, I'll just do it in black, cos of A will equal adjacent 12/13. Okay, but we've just got to check, right, that would be, okay, if A was acute. We were told that A was obtuse. Now, if you think about your cast diagram, I'm just going to draw it here. Okay, remember your cast diagram tells you where your angles, where your trig ratios are positive. So remember C, A, S, T. So if you notice, A is obtuse. So A is between 90, I'm just going to colour it in, is between 90 and 180. And therefore, only sine will be positive, because between 90 and 180, we've got S in that section. So therefore, cos A equals minus 12/13, as A is obtuse. So we've got to be very, very careful, and again we've got to just think about what this is telling us. And again, I'm going to go back. Now cot, okay, cot, right, is 1 over tan A. Okay. So if we have a little look, you can see that tan A, of course, is opposite over adjacent, 5/12. But that will be if A was acute. Okay, tan of A equals, well, we said that only sine, look at your cast diagram, only sine will be positive. So tan of A will equal negative 5/12 as A is obtuse. Therefore, we're going to have 1 over negative 5/12, which equals negative 12/5. Okay, so you've got to be a little bit careful. So again, first thing you do to find, your ratios, pretend that A is acute, find the ratios, and then look at your cast diagram to decide whether you're going to be negative or positive. So let's have a little look at this question. It says, given that tan A is negative 3/4 and that A is reflex. Now be careful, reflex is between 180 and 360. So again, we're going to have to be very, very careful with what we're doing. Okay, so find the exact value of sine A, sec A and cot A. So again, we're just going to use this information. At the top, I'm going to draw a right angle triangle. Again, I'm going to pretend that A is, first of all, A is acute. Remember, tan is opposite over adjacent. So by Pythagoras, the hypotenuse will be 5. And also I'm going to do a cast diagram, 0, 90, 180, 270, C, A, S, T. Now, you can see that we were given that tan of A was negative. Now, tan A is positive if it's between 180 and 270. Therefore, that tells me that the angle I'm dealing with is between 270 and 360. And therefore, only cos will be positive. Okay, so let's work on sine first. Sine A, of course, sine A will equal, well, that's opposite over hypotenuse, that's 3/5, if A is acute. So therefore, sine A, sine A, and we know that it's between 70 and 360, so only cos is positive, so it must be negative 3/5 as A is reflex. Okay, sec A. Okay, so we know that cos A equals 4/5. Okay, therefore, sec A, remember, because sec A equals 1 over cos A, which equals 1 over 4/5, which equals 5/4. And the last one, the easy one, cot A, is 1 over tan A, which equals 1 over minus 3/4, which will equal minus 4/3. Okay. Last one. Again, we'll have a little look at this one. Again, think about this one. I'm going to let you do this one on your own. You're given that tan A is negative 7/24. A is obtuse, so A is between 90 and 180. Again, follow the procedure. Pretend that A is acute. Draw a right angle triangle. Draw your cast diagram so you know which ones you're doing, and then you can check your answers on the model solutions. Now we're going to go on to look at solving equations, and again, with solving equations, very important that we just plot, first of all, whether we're looking in degrees or in radians. Okay, remember, we can only solve equations where we've got sine, cos and tan, because we're going to have to do inverse sine, inverse cos, inverse tan, and therefore we need just to make sure that we turn it into the right trig function. So we've got sec theta equals root 2. So if sec theta equals root 2, then we know that sec theta is 1 over cos theta equals root 2. Therefore, cos theta must be 1 over root 2. So we've done the reciprocal. Okay. Theta, therefore, is cos to the minus 1 of 1 over root 2. Okay. We pop that in our calculator. We are working in degrees, so we need to make sure our calculator is working in degrees. The principal value comes out at 45 degrees, and you can use a cast diagram if you want to. C, A, S, T, 0, 90, 180, 270, 45 degrees goes there. Okay, we do cos of a positive, so that goes there. So you can see the other solution, therefore, will be 315 degrees. Okay. Number 2, be very careful. This time we're working in radians. Okay, so we need to make sure our calculator is working in radians for us. And we're solving cosec alpha equals -3. Now remember, cosec is 1 over sine alpha equals -3. Therefore, sine of alpha equals minus a third, negative a third. Alpha, therefore, is the inverse sine of negative a third. And of course, we want all the solutions between 0 and 2 pi. So, first solution comes off the calculator as negative 0.3398. And I'm working to 4 significant figures, so my final answers will be to 3 significant figures. Now you'll notice that principal value that comes off is not one of the solutions we actually want, but we need it to find where the other ones are. Again, cast diagram, this time in radians, pi, 3 pi over 2, C, A, S, T, and negative 0.33, that's down here, 0.3398. We were doing sine of a negative. Where else is sine negative? It's here in the tan section, 0.3398. So actually the 2 answers we want is pi plus 0.3398, which comes out as 3.48 to 3 significant figures. And this one is 2 pi minus 0.3398, which comes out as 5.94 to 3 significant figures. Right, number 3, is 5 cot beta equals -2. And again, we're back in degrees again. Okay, so we need to make sure our calculator is working with us. First thing we need to do is rearrange it to get the cot beta on its own. So cot beta equals -2/5. Remember, cot is 1 over tan, so I'm going to go straight for it this time. Therefore, tan beta must be -5 over 2. You can jump straight to that. So beta is tan to the -1 and -5 over 2. Again, beta equals minus 68.199, which is not one of the solutions I want, but it's the solution I need to put on my cast diagram. C, A, S, T, negative 68.199 comes down here. Again, I was doing tan of a negative, so that's across here. This angle is 68.199. So the 2 solutions I want between 0 and 360 beta equals, it's 158.2 this time. I'm working to one decimal place. Again, in the question, you will be told what accuracy to work to. If you have a look at number 4, you can see we've got a squared. Now, whenever we get a squared, we're going to be working with two possible equations. We're going to be very careful in radians, and this time we're going from negative pi to pi. So the first thing I want to do is rearrange it to get the sec squared on its own. So I'm going to get sec squared theta equals 4/3. Remember, sec squared is 1 over cos squared theta is 4/3. Therefore, cos squared theta is 3/4. Right. We're going to solve it. I'm going to square root both sides. Remember, when you square it, you get two answers. So you're going to get cos theta equals, and it's going to be plus or minus root 3 over 2. We're going to solve those separately. Okay, so we've got cos theta equals root 3 over 2. Theta equals cos to the minus 1 of root 3 over 2. Make sure you're working in radians. Okay, and you get theta equals pi over 6. And remember, because cos is symmetrical, that will also be negative pi over 6. Or I'm going to do cos theta equals negative root 3 over 2. Okay, theta equals cos minus 1 of negative root 3 over 2. Theta equals, again, pop that in your calculator, you get 5 pi over 6, and again, the other solution will be negative 5 pi over 6, because, of course, the cos wave is symmetrical. Okay. Right. We'll have a little look at this one. Okay. So this is 5 cos 3x equals 3 cot 3x. So the first thing we're going to do with this, so there's lots and lots of solutions here, so we've got to be very, very careful. All right, so the first thing we're going to do is do 5 cos 3x equals 3, and cot, of course, is cos 3x over sine of 3x. Okay, now be very careful. The next move is not to divide through by cos of 3x. If you do that, you're going to lose half of your solutions. We're working in radians and we want all the solutions between 0 and pi. Now you'll notice that the angle I'm working with is 3x, so I'm just going to change this. So in other words, when I work on my cast angle, I need to go as far as 3 pi to make sure I get all the solutions I need. Right, okay, so the first thing I'm going to do is multiply both sides. So I get 5 cos 3x sine of 3x equals 3 cos 3x. You'll notice cos of 3x is common to both, so instead of dividing by it, which will lose half our solutions, we're going to bring it all onto one side and we're going to factorise. So 5 cos 3x sine of 3x minus 3 cos of 3x equals 0. We're going to pull out cos of 3x as a common factor, and we're left with 5 sine of 3x minus 3 equals 0. So we've got two possible solutions here, or equations to solve. Cos of 3x equals 0, or sine of 3x equals 3/5. Right, now this first one, cos of 3x equals 0, you should be able to state that 3x equals, okay, pi over 2, because you know what the cos graph looks like. Where does the cos graph hit 0? It's pi over 2, 3 pi over 2, and 5 pi over 2. Okay, and therefore x must be pi over 6, pi over 2, and 5 pi over 6, which of course are all between 0 and pi, which was the values we wanted. Now, this one, sine of 3x equals 3/5. We're going to solve that. And this one I'm going to use a cast diagram for. So 3x equals sine to the minus 1 of 3/5. So 3x equals 0.6435. Now remember, that's your principal angle, and that's going on our cast diagram. That's my cast diagram. 0, pi over 2, pi, 3 pi over 2, C, A, S, T, and 0.6435 is about here. 0.6435. We'll be doing sign of a positive, so here's next one, 0.6435. And remember, we need to keep going round until we get to 3 pi. So we're actually going to end up with 4 solutions. Right, so the first one, of course, is 0.6435. The next one is pi minus 0.6435, which is 2.4981. The next one will be 2 pi plus 0.64, that's 6.9267, and we want 3 pi minus 0.6435, which is 8.7813. Then we're going to divide each of those by 3. Okay, so we get 0.215, 0.833, 2.31, and 2.93, which of course all come in between 0 and pi. So we end up with 7 solutions for that question. Now, the next one, just be a bit careful. I think there's a misprint on your notes. It has something after the 0 that you need to just cross out. Okay, now this one, again, it's cot squared and minus 8 tan x. So remember, cot squared is 1 over tan squared x minus 8 tan x equals 0. Again, we're working in radians, so I'm going to make sure our calculator's working in radians. Multiply the whole thing by tan squared, so we get 1 minus 8 tan cubed x equals 0. Rearrange that to get the tan cubed on its own. Tan cubed x equals an eighth. Okay, therefore tan x, when we cube root of an eighth is half. X equals tan to the minus 1 of a half. X equals 0.464 and 3.605. So I'm just working both of those to 3 decimal places. Okay. Again, remember with tan, once you've got your principal angle, you can just keep adding multiples of pi to get what you need. Okay. Now, the very last question we're just going to have a little look at. Okay. And this one again is, I'm going to start you off on this one again. You can check your answers. Be very careful. The angle is 2 alpha, and we want solutions for alpha. We're working in degrees. So this one again is 2 sine 2 alpha equals 1 over sine of 2 alpha. Okay, you're going to end up with a sine squared. You're going to end up with 2 equations to solve, a positive and a negative, and you're going to end up with answers. I'll give you the answers that you should be aiming for. You should aim up for alpha equals 22.5 degrees, 67.5 degrees, 121.5 degrees, and 157.5 degrees. So 4 possible solutions. The first 2 are from the positive sign, and then the second 2 are from when you get the negative one. Right, we're just going to have a little look at this exam question. Okay, this exam question says, in the diagram, AB is 6 centimetres, is the diameter of a circle, and BT is a tangent to the circle at B. The chord AC extends to meet this tangent at D, and the angle DAB is theta. Show that CD is 6 bracket sec theta minus cos theta centimetres. Okay, we'll have a little look at this one. So the first thing you need to realise is this has got one or two things to do with, it's got basic trigonometry, and you can remember A, B, D is a right angle because radius meets a tangent at right angles. And also, I'm going to put it in red, if you line up, if you join C to B, because AB is a diameter, then angle ACB is right angled, and that's quite crucial to this question. Okay, so let's have a little look. So I'm going to go through this one. So we've got angle ACB is 90 degrees, and that's because triangle in a semicircle is a right angle triangle. Okay, therefore AC equals 6 cos theta, and that's basic trigonometry. Okay, cos theta is adjacent to a hypotenuse. Okay, and therefore AC is 6 cos theta. But angle AED is 90 degrees because that is radius to tangent. And again, we're going to do a similar thing with the big triangle this time. So, okay, you can say cos theta equals 6 over AD, because AD, of course, is the hypotenuse. Therefore, AD equals 6 over cos theta, or AD equals 6 sec theta. Now, therefore, CD is AD minus AC. We know that AD is 6 sec theta, and AC is 6 cos theta, and therefore we just pull out 6 as a common factor, and we get sec theta minus cos theta, which is what they wanted. It then says, given that CD is 16, calculate the length of the chord AC. If we put in what we know, so we can get 16 equals, and it's 6 over cos theta, which of course was 6 sec theta, minus 6 cos theta. If we cross multiply, we get 16 cos theta equals 6 minus 6 cos squared theta, rearrange to get a quadratic. 6 cos squared theta plus 16 cos theta minus 6 equals 0. And use our calculator to solve that quadratic. We get cos theta equals a third, or cos theta equals -3. And of course, that one has no real solutions. So I'm going to discount that one. Okay. Now, in part A, we have this statement that AC was 6 cos theta. Therefore, AC must be 6 lots of a third, so AC equals 2 centimetres. Okay. Right. Now, the last one we're going to look at is this one, and again, it's a proof question. Okay, so I'm going to start left-hand side and try and get it to be the right-hand side. And we've done something similar to this already. So remember, cosec is 1 over sine of x. Okay, so we're going to start with the left-hand side. And the left-hand side is cosec x minus cot x over 1 minus cos x. So cosec is 1 over sine x, and cot is cos x over sine x, and that's 1 minus cos x in the denominator. Again, if we do fractions on the top, we're going to get sine x minus cos x all over sine x. Sorry, apologies, start that one again. So on the top we've got 1 minus cos x over sine x, and that's over 1 minus cos x. I'm just going to have to jump up onto this side. I'll jump onto here. So you've got a fraction on top, you can drop the denominator, so it's 1 minus cos x over sine x bracket 1 minus cos x, and of course the 1 minus cos x top and bottom cancel out, so you're left with 1 over sine x, which of course is cosec x, which is the right hand side. Okay, cos. Now, it then says, hence solve between the interval negative pi to pi this equation. Now, what you'll notice is that this bit here we can replace by cosec x, because it's exactly what we got on the other side. So we can have, therefore, cosec x equals 2. Remember, cosec is 1 over sine, so sine x equals a half. Okay, first typical both of them. X equals sine to the minus 1 over half, and don't forget we're working in radians. X equals, it's pi over 6. You use your cast diagram. Pi over 2, pi, 3 pi over 2. We've got pi over 6, which is here. Okay, the sign of a positive. This is pi over 6 as well. C, A, S, T. So the only other solution is 5 pi over 6, because there are no solutions in the negative pi area. Okay. Right, so that's the third video finished for reciprocal trig. So hopefully you can start practicing and you will get better and better.